Hello students and welcome to this video. In this video we will solve question number 481 to 490 of permutations and combinations. The link to download the PDF will be in description as well as at the end I will show you how you can have an updated copy of the books which I have written and the question answer website where you can come and ask questions. So without further ado, let's get started. Question 481 says that find the number of ways to pave a 1 times 7 rectangle by 1 times 1, 1 times 2, 1 times 3 tiles if tiles of the same size are indistinguishable. So if there is 1 times n paving is there, then what we can do is we can think of it as 1 times n minus 1 with 1 times 1 at the end, or 1 times n minus 2 with 1 times 2 at the end, or 1 times n minus 3 with 1 times 3 at the end. So the reference relation which we have is Fn is equal to Fn minus 1 plus Fn minus 2 plus Fn minus 3, where n is greater than equal to 3. And our base cases are f0 is equal to 1, f1 is equal to 1, f2 is equal to 2. So we get f7 is equal to 44. If you don't understand this question, please ask question on the website. I will show you how we get this reference relation and how we get base cases. These are fairly trivial. Question 482 says that find the number of distributions of 5 distinguishable balls and in 3 distinguishable cells if empty cells are allowed and if empty cells are not allowed. So for the first part, number of ways are 3 to the power 5, that is 243. For second part, number of ways are r to the power n minus rc1, r minus 1 to the power n, rc2, r minus 2 to the power n, putting n is equal to 5 and r is equal to 3 in our equation, we get 3 to the power 5 minus 3c1 to the power 5 plus 3c1 1 to the power 5, which is 150. Again, if you don't understand this formula, let me know and I'll explain this to you. Question 483 says that how many terms are there in the expansion of a plus b plus c plus d whole raised to the power 24? So the terms will have form k dot a into e1, a raised to the power e1, b raised to the power e2, c raised to the power e3, b raised to the power e4. Where k is a constant and ei varies from 0 to 24 such that their sum is 24. The problem is equivalent to distributing 24 identical balls in 4 distinguishable boxes where empty boxes are allowed. So the sum is 24 plus 4 minus 1, C24, that is 27, C24. Question 484 says that find the number of ways of distributing 5 identical balls into 3 boxes so that no box is empty and each box being large enough to accommodate all the balls. So number of ways of dividing n identical balls into our boxes so that no box remains empty is n minus 1 cr minus 1, that is 4c2 is equal to 6. Question 485 says that find the number of ways of distributing 10 identical balls in 3 boxes so that no box contains more than 4 balls and less than 2 balls. So number of ways of distributing balls is equal to number of integral solutions of the equation x1 plus x2 plus x3 is equal to 10, where xi is between 2 and 4 and I varies from 1 to 3. So that is coefficient of x to the power 10 into n x square plus x cube plus x raised to the power 4 whole cube. We take out x square common, so it will become x to the power 6. So we got x to the power 4 in 1 minus x cube to the power 3 multiplied by 1 minus x to the power minus 3, which we evaluate to be 6. Again, this question requires binomial theorem of an index, without which you cannot solve it. So if you have not studied binomial theorem for an index, we can skip the question. Question 486 says that find the number of ways in which 14 identical toys can be distributed among 3 boys so that each boy gets at least one toy and no two boys get equal number of toys. So let the boys get a comma a plus comma a plus b comma a plus b plus c toys respectively, such that a, b, c are greater than or equal to 1. So in this case, they will not get same number of toys. So 3a plus 2b plus c is equal to 14, and all are greater than 1. So quotient of x to the power 14 would be x cubed plus x to the power 6 plus x to the power 9, multiplied by x squared plus x4 plus x to the power 6 and so on, and x plus x squared plus x cubed. So this will go in the powers of 3, that is this one, and 2b will be this one. So we take x3 from here, x2 from here, and x from here. So we get x6. If we subtract, we get x to the power 8, then 1 plus x squared plus x cubed, 2x to the power 8, multiplied by 1 plus x squared up to x to the power 8. So the quotient is 10. Since those numbers can be assigned in C factorial ways, the total number of ways is 60. Question 487 says that find the number of distribution of 5 distinguishable balls in 3 identical boxes, and 2 boxes are allowed. So required answer is S5, 1, S5, 2, S5, 3 into S5, 1. So we are given 5 distinguishable boxes. We can put all them in first box, or all of them in second box, or and so on. S5, 2 is 2 to the power 5 minus 1 minus 1. So that is equal to 15. And S5, 3 is S4, 2 plus 3S4, 3, that is 25. So the answer is 41. Okay, I think I made some mistake. This should be 41. Yeah, that's right. So several combinations are possible, and we have the answer as 41. So now question 488 says that, let me try to explain this a bit more. Let me try to understand the notation. It has been quite some time since I solved this problem. So 5 distinguishable boxes from 3 identical boxes. Okay, 5 goes in 1, all goes in 2, all go in 3 and 1. All cannot go in 3 and 1. It means I'm not sure what does it mean. Let me think. So let me think. Distribution of 5 distinguishable balls in 3 identical boxes. I will explain this a bit more later, probably in the next video. I'm not sure how to identify this. Apologies for my tardiness, and we will see this problem in the next video. Question 488 says, what is the number of necklaces that can be made from 6 identical blue beads and 3 identical red beads? So required answer is P3 6n plus P2 6n plus P1 6n. We know that PKB minus PKN minus 1 is equal to PK minus 1 and minus 1. So P3 6n minus P3 6n minus 3 is equal to P2 6n minus 1, which is equal to floor of 6n minus 1 by 2, that is 3n minus 1. So P3 6n minus 3 minus P3 6n minus 6 is equal to P2 6n minus 4, that is 3n minus 2. And similarly, we go on computing, we get P3 6n minus P3 6 is equal to 3n squared minus 1. And P3 6 is equal to 3. So P3 6n is equal to 3n squared, P2 6n is equal to 3n, P1 is equal to 6n is equal to 1. So the answer is 3n squared plus 3n plus 1. Again, I'm not sure what these symbols mean. So 2 questions are pending with me, okay? 487 and 488 I'll explain in next video. Find the number of ways in which n distinct objects can be put into two different boxes, there should not be V, so that no box remains empty. So total number of ways is 2 to the power n. However, in two of the ways, all balls go in each box. But the question says that boxes cannot remain empty. So the answer is 2 to the power n minus 2. Question 4 says that find the number of ways in which n distinct objects can be kept into two identical boxes so that no box remains empty. So the question is n different objects into two identical boxes. Okay. So again, the same symbol has come, Sn minus 2. Okay, Sn comma 2. So 3 questions I will solve in the next video. I will have to refer to my notes. I have written this in a very concise manner, so I should have explained this in the question. So 487, 488 and 490 I'll explain in the next video. Now I will show, and I'll also update the PDF with the description. Now I'll show you the website where you can come and download the books. You can come to my website ashtabak.org and download algebra from the second link, trigonometry from third, and fourth coordinate geometry. So when you download, you add dates to the files. Those do not have dates. The reason is that if I put dates in file names, I cannot update the links in YouTube videos because there will be a huge number of links. So when the file changes, this date changes, and we get sorry, when the file when I update, the date changes and you can update your copy. So you should come repeatedly, probably once in 15 days or a month, and see if a new version has been released. About the question answer website, you can come to tundika.ashtabak.org and ask questions here. So for algebra questions, you can make use of algebra tag. For calculus, trigonometry, and coordinate geometry. Okay. So here you can type the math. I'm working on the help file for Markdown, so it should be completed within a few days. So this will help you how to ask questions. Okay. And with this, I will end this video here. Once again, I apologize for not explaining the symbols S and T3. So we will see these in the next video. I'll update these 3 answers. So I hope that your studies are going well and you're enjoying this series of videos and finding it useful. So we will meet again tomorrow with 10 more problems, and I'll take my leave here. So keep learning and enjoy. Have a great day. Bye.